The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS, welcome to today's webinar on dimensions of test coverage. I am Rex Black, president of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, over 21 years, RBCS has delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants who deliver customized training, consulting, and outsourcing services to companies that are looking to improve their test and quality assurance practices. I'm the author of 11 books on software testing, including the bestseller Managing the Testing Process, and 4 books on the ISTQB program. Attendance at today's webinar earns PMI PDUs. Thank you, Linda Thorne, for reviewing the materials and making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. Before we start the presentation, a couple notes. If you have any questions during the course of the webinar, submit them at any time, but please note that they are answered only at the end. There is no need for presentation copies. The presentation is already posted on the web. Go to rbcs-us.com, find the resources tab in the upper center of the page, and navigate to the basic library. By attending this webinar, you have automatically been registered for the free e-learning drawing. Check your email over the next couple days and watch the spam filter. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. Now, today's presentation is on the dimensions of test coverage. Now, I run into some interesting comments every now and then, or on the blogosphere, Twittersphere, whatever you want to call it, social media, postings of various kinds, where people talk about coverage and they make some basic mistakes about it. Like, for example, people talk about coverage meaning running all of your tests. Well, that's a circular argument, of course, because what do the tests actually cover, right? They don't cover themselves. The tests have to cover something, right? So we need to be clear that when we talk about coverage, when we talk about tests covering something, we need to be clear on what that is that we are covering, and clear to ourselves and also clear to people outside of testing. Just saying, oh, we've run all of our tests and therefore we've covered everything is not adequate. How do you know that you've covered it? How can you prove that you have covered it? What are the ways of measuring coverage? What are the things that should be covered? So that's what we're going to look at today, and hopefully this will help expand your thinking on test coverage and what tests should cover and what they can cover, going beyond just simple requirements. Okay, maybe the slide will advance. Had some odd behavior with this computer earlier. Has some very strange behavior with it, but hopefully it's better now. Okay, so why do we care about coverage anyway? Well, one of the things that we typically want to do in testing is to build confidence, and the confidence building is in two areas. Okay, for one thing, we want to build confidence in our testing. Did we actually test properly and sufficiently? Did we test everything that needed to be tested? And assuming that the test results are looking good, what can we say about the system's operation? Can we have confidence that the system works properly? So those would be the two areas where we're trying to build confidence. And notice that we can't address those unless we can talk about what we tested. And again, not just what tests we ran, okay? The tests are by themselves are an abstraction of what is supposed to be addressed, and what we want to be able to say is these are the areas of the system that we have covered, we have tested, not here's 150 or 250 or 500 test cases that we've run, because those test cases could be redundant, irrelevant, etc. Now, of course, building confidence is not the only thing that we're trying to do in testing. Other objectives would be finding defects, and of course the testing of important areas is how we're going to find the important defects. So again, back to coverage. Reducing risk to an acceptable level is another typical objective, and again, we can only reduce the risk to an acceptable level if we can say what the risks are and whether we have covered those risks. All of this comes down to generation of information, basically, that the testing does not generate a product per se. It generates a work product that is information. And the information should be relevant to people and timely so that it supports proper decision making. How close are we to done with the project? Is the product ready to release, etc. Now, all of these are measurable. This is not something that needs to just be some sort of hand-waving exercise or trust me, I've got this, it's handled. You want to have metrics that are going to be able to say, what has been covered, what hasn't been covered, what works, what doesn't work, where are there known defects, what are those defects, how many are we finding, what risks have been addressed, which have not. So this should all be something that we are reporting. Now, I've addressed test results reporting in other webinars, so I'm not going to get into it here, but certainly if that's something you're curious about, I'd encourage you to listen to one of the recorded webinars that addresses it. All right, so dimensions of test coverage. So usually when the relative newbies to testing use the word coverage, they either, as I said, mean coverage as in running the test cases, which is incorrect, as I said, because that's a circular reference there. But if they're not making that mistake, then when a testing newbie says coverage and you ask them what coverage of what, they say, well, the requirements, of course, or if they're in Agile, well, the user stories, and then that's sufficient. Well, it is certainly a necessary thing to cover the requirements. So you should certainly have at least one test for every requirement, and usually more than one. So it's necessary, but by itself is not sufficient. So there are other things that that we need to look at and consider. Now, not all of these dimensions of coverage are relevant to every testing effort, but they should all at least be considered as part of planning and planning your tests and analyzing the project and product to determine what your test conditions are, what you want to cover. So we need to look at risks, code coverage, white box types of coverage, configuration coverage, data sets, personas, and defects. And now I'm not saying that these 7 are the only dimensions of coverage, but these are certainly important dimensions of coverage that should be considered. And of course, if anything else is relevant, you should also consider that. So let's look at each one of these and consider each one of the dimensions of coverage. So we'll start with specification coverage, requirements coverage, user story coverage, use case coverage, whatever they give you that tells you how the system's supposed to work. So what you're doing here is looking at the specification, which is going to define either how the system is supposed to behave, or in the case of a design specification, how it's supposed to be built. And as I said, we want to have these defined elements ideally clearly listed out as specific elements. And for each one of those elements, we want to have at least one test, and we want to be able to determine for each of those elements whether the associated tests have passed or failed, because that will tell us whether the requirement appears to be fulfilled or is suffering from known problems. Now, this is all relatively easy to do with any any test management tool that you would actually want to have will be able to do this for you. You input the requirements into the system. There's usually a separate table that holds those, and then as you create the tests, you associate the tests with the elements of the requirements. Sometimes that's referred to as traceability, and that would be in the tool, and then you can report. Usually not in a native fashion, but you can export the data and create a report, an example of which I'll show you in a minute. Create a report that shows the status of the requirements in terms of which ones are known to work, at least under tested conditions, and which ones are known to not work. So this is certainly very useful in terms of looking at where have we tested, where have we not tested, what remains to be done, where are there problems with the system. But it's important to keep in mind that this dimension of coverage is only as good as the requirements or design specifications which we've received. And historically, those have not been very good. So Capers-Jones's studies indicate that about 45% of defects are introduced either in the requirement specification or in the design specification or design process. So if you're using a specification of behavior or structure to determine what to test, you're basically half wrong in the sense that any defects that are in that document are likely to end up as defects in your tests, and gaps in that document will end up, of course, as gaps in your tests. So that is an important thing to keep in mind. I'm certainly not saying don't test the requirements. Obviously, you must do that, but don't think that by doing that you have done anywhere near all you need to do in terms of coverage. So here's an example of what I'm talking about in terms of reporting of coverage. So this in this chart, what we see is that there are 6 major subsystems, and this is hypothetical based on a actual testing dashboard that I built for a client. So we have 6 major subsystems, A through F. Of course, in the real life, those would be given actual subsystem names, right? And what we see are 2 data sets being graphed for each of the subsystems. So the green and red bars represent the passed and failed tests for those subsystems, and the blue and yellow bars represent the closed and active defects. So this is established via traceability. We have traceability of the test back to the major subsystems, and actually it's more detailed than that, but this is we're aggregating here. And this can be very useful in terms of knowing where we stand. So if you look at subsystems D and F, 100% of the tests have been run. So of the tests that trace back to subsystems D and F, they've all been run. F is clearly in somewhat better shape in that there is a very small percentage of failed tests and active defects. D is in somewhat worse shape. It's about 20% of the tests have been failed, and there are more active defects. But still, at least we know where we stand with subsystem D. Now, subsystem C. Initially, you might say, well, that looks good. It's all green and blue. Yeah, but 80% of it hasn't been tested yet, so it's kind of an open question as to what the status of that is, right? B is clearly the worst off of them. Very few tests have been run relatively, and all of them are failing, and it has the largest number of defects, and most of them are active. So D is clearly in a lot of trouble. Excuse me, a quick cough there. So you can see very quickly with a chart like this, what's the status of our system based on here again. This is a major subsystem, so it's a structural look. Like you say, it's also kind of a functional look because the subsystems are um, providing in this case certain functionality. So you can do this also with requirements and based on functional and non-functional requirement groups. Be another way of organizing this chart. Okay, so risks. We can identify and should identify risks to the quality of the system. Now, what do I mean by a risk to the quality of the system? Well, basically, that's a possibility that the system might misbehave in some way. For example, system calculates an incorrect total on a yearly or monthly sales report. User finds the account update screen difficult to understand and navigate. System responds too slowly to user input during login. So those were three examples of quality risk. The first was a functional risk. The second two were non-functional, specifically usability and performance. So you can identify both functional and non-functional risks. And then what you do is you identify the risks, you assess the likelihood and impact to come up with an aggregate measure of the level of risk. And you can use the same trick that I mentioned before, which is where you capture, in this case, the risks in the requirements tool. You usually have to kind of diddle around with it a little bit, like, for example, Quick Test Pro or Quality Center, HP's tool, which I think now goes by a different name, but was previously called Quality Center. That's the name I always associate with it, or before that it was Test Director. You have to customize it a little bit to get it to support proper risk-based testing. It's not out of the box, it doesn't do it quite right, but it doesn't take a whole lot of tweaking to get it set up properly. And then you're basically, as I said, capturing the risks as if they were requirements in a special hierarchy in the requirements area. And when you create the tests, you again capture traceability of the test back to the risks. Now, a test can relate to both a risk and a requirement, so you can have that relationship. And in addition, you often want to establish traceability between the tests the risks and the requirements, so that if a requirement is updated, then you know to update the relevant risk. So once you do that, as you run the tests, you can report your level of residual risk, and I'll show you an example of that. Again, this is not a native kind of report at least in any of the test management tools I'm aware of, but it's easy enough to dump this information out and use Excel to create it. And by the way, the examples of the results reporting spreadsheets that I'm showing you that were used to create these graphs are all available for free download on the RBCS website, either the basic library or the advanced library. Let's see. So strengths here. You will be able, as you're about to see, you'll clearly be able to visualize what the residual level of quality risk is, and actually will allow you to drill down, as it were, for reports in detail. But you do have to do your quality risk analysis properly, because if you are missing risks, just like with missing requirements, that will lead to gaps in your coverage. Now, I've given a number of webinars on risk-based testing, and so those are recorded and they're on the digital library. There's also on the digital library about 8 hours of videos on risk-based testing, various topics related to it. So if you're not familiar with risk-based testing and you're thinking, how do I go about putting this into action, take a look at the digital library. Okay, so risk coverage, an example of how to do that. So what we see here in the in this pie chart is the risks being classified in one of three buckets. So basically, if we have a risk item and all the tests that are associated with that risk item have been run and they all pass, we classify that risk as green. Basically, that risk is fully mitigated. Now, of course, fully mitigated here means to the extent to which we intend to mitigate it, right? I mean, it doesn't mean there's zero risk here, but it's as good as it needs to be in our professional judgment. Now, if one or more of the tests that was run against a risk has failed, then the risk is going to get classified as red. So it's a known problem area. Otherwise, if it's neither green nor red, it's black, and basically what that means is no tests have failed yet, but there are still tests left to be run, so we don't know everything that we want to know about it. So when you first start testing, when you first start your test execution, the pie chart is going to be all black. As the testing continues, what you would expect is initially the red wedge is going to grow disproportionately fast, and then as the system starts to stabilize, you're then going to get the green wedge growing, and then you would hope that at the end of your test execution period, you'd be looking at something like the pie at the right side of the chart, which is showing that almost all the risks are in green status. We got about 4% where there's still some tests pending, and about 1% where there are some known failures. And notice that we can use traceability to go directly down into the specific risk items that are in the black and the red wedges to determine whether that residual level of quality risk is acceptable. Now, suppose that you were working in an Agile environment, you could do something very similar to this by simply expanding your task board and the way your task board is defined such that you have risks going into, well, they start off in the black. Once testing starts for a particular risk, you would put that risk in the black, and then you could move it into red or green as appropriate, and then hopefully ultimately into green. But if not, any risks that remain in the red or the black columns could be addressed by the team as to whether they are considered to be acceptable risks. Now, here is a dimension of coverage that many people are familiar with. This is this idea of white box coverage, and typically that when people are talking about white box coverage, they are talking about code coverage. There are kinds of white box coverage that include data flow analysis, which is interesting because it's possible to achieve very high level of white box code coverage and still be not covering all of the different possible data flows. But most time when people are talking about white box coverage, they are talking about code coverage. Now, there are different kinds of code coverage, and a lot of people are not very familiar with those kinds of coverage. So I'm going to address that on the next slide. Now, this is very useful, particularly for unit testing. I'm of the opinion that companies should adopt strict standards for unit testing in terms of code coverage, which I'll address when we talk about code coverage in the next slide. Now, you have to be careful with it though, because it is telling you that a particular element of the code was exercised, and it's not telling you whether the test which exercised it is actually a good test. It might not be a very good test. All it says is you've touched this piece of code. Another thing to be careful with too is that even really excellent unit tests are generally only going to get about 50% of the defects. This is Capers-Jones's findings and studies on these effectiveness of these. So you don't want to be overly confident about about the completeness of the unit test based on code coverage. And of course, the code coverage is only telling you you tested what's there. It can't tell you there's something that should be there that isn't, right? So if there's missing code, you're not going to find that, because it's basically just telling you how thoroughly you've exercised the code. You also want to be careful with using it for higher levels of testing, like system test and system integration test. It can be a useful way of identifying gaps in your tests, but generally you do not want to have code coverage as a primary dimension of coverage for system test or system integration test. That's something that should really be addressed at the lower levels of testing. This is a real hassle to try to measure manually, but fortunately there are plenty of tools out there, many of them free, which will allow you to measure code coverage. For example, if you're in a Linux environment, you can use gcov to do that. Now, the tools aren't always perfect, and they for example, with gcov, there is a bug in it such that you can achieve 100% branch or decision coverage, which I'll talk about in a minute, and yet the tool will show you as not having achieved 100% statement coverage, which is impossible. So you have to be aware that there can be some bugs in these, but still it's better than trying to do it by hand. So in terms of statement coverage, code coverage, is basically two primary ones that are commonly used. There's the statement coverage, which is the percentage of executable statements that have been executed at least once by a test. And then you have decision coverage. So anytime you have an if statement or a loop or a switch case construct or something, you have branching or decisions that goes by either name. It can be called decision coverage or branch coverage. It means the same thing. Basically what you have to do is you have to look at all of the where the flow through the code forks. Every one of those is a possible outcome. Every fork point or every branch coming out of the fork is basically a possible outcome. So we can measure coverage in terms of how many of those possible outcomes, true or false, true and false, have been taken. And to me, the standard ought to be that 100% statement and decision coverage is minimal level of code coverage for an acceptable unit test. Basically, if developers aren't achieving that, there is untested code and logic in their program, and that basically means they're counting on someone else to test it, and who knows who that somebody else is going to be. Possibly you as a tester, but possibly a customer. Now, a higher level of coverage is that is in practical use is what's called modified condition decision coverage. Now, condition coverage is basically saying, if you look at the underlying conditions in the if statements and loops and so forth, have each of those what are called atomic conditions, the smallest breakdown of the conditions within the if or loop. Conditions been at least once true and at least once false. Well, it turns out that condition coverage by itself is not very useful, but modified condition decision coverage is. This is the level of coverage that has to be achieved in avionics software where for anything that's safety critical. And it basically says that not only do you have to do both the true and the false side of the branch, that's the decision coverage, and not only does every condition have to have been at least once true and at least once false, but also each of the atomic conditions has to have made the overall decision true once and the overall decision false once, meaning that basically what you're testing is if there's any situation where a condition is supposed to evaluate to true but it actually evaluates to false, or vice versa, the program would do the wrong thing and you'd be able to detect that in your testing. So that is a useful metric. Multiple condition refers to testing all the possible combinations of conditions, which is no longer used because modified condition decision coverage is a lot cheaper in terms of the number of tests and is believed to provide about the same level of risk mitigation. Now, the other thing that you might run into is what's called basis path coverage, which is pretty much the same as decision coverage. So if you've got a tool that's focused on the whole McCabe, cyclomatic complexity, and so forth, it might be talking about basis paths. There is a slight difference between basis path coverage and decision coverage, which, if you're curious, you can read about on the internet, but they're basically the same thing. The thing about the basis path coverage is it does provide as a nice side effect, if you will, bonus byproduct, the calculation of the cyclomatic complexity, which is a good way of thinking about whether the code is excessively complex and difficult to maintain. So that can be a helpful metric. But, again, most of this stuff is going to be developer focused at the unit level. As a tester, it's good for you to be familiar with these levels of coverage and what they mean, and so that you can have a conversation with your developers about their unit tests. And don't be surprised if you find that you're actually educating them on some of this stuff, because as I said, a lot of developers are not as familiar with this as one might hope. Now, here's another very important element of coverage that people sometimes forget about, though not, I don't think as much. They don't forget about it as much now as in times past. This is the identifying the different supported configurations and looking at how thoroughly we have tested them. And it's either done via what's called equivalence partitioning, which I hope most of you are familiar with, where you identify the different, say, types of browsers and security software and operating systems and so forth that you're going to support, and making sure that your test environment includes at least one instance of each of those. Or in some cases, people use what are called pairwise techniques to generate all possible pairs of options across all the different factors involved. So the browsers with operating systems, browsers with security software with operating systems, looking at those different possible pairs. Personally, I think pairwise testing is overused. It got really hip for a while and sort of went through its own little Gartner hype cycle. I think that's starting to wear off, but there's still people out there pumping tools for this and pumping the technique and making money off it. So unfortunately, as long as that's out there, there are going to be snake oil salesmen who are pushing it for its use where the level of risk really doesn't justify it. I actually did a webinar called Myths of Pairwise Testing, where I address this, and you can listen to the recorded webinar if your company is one of those companies that's suffering from the mass hysteria that accompanied pairwise testing about 4 or 5 years ago. And by the way, if you're paying for a tool to do your pairwise analysis, stop now. Stop paying the license fees. Go out to the National Institute of Standards and Technology, NIST.gov, and download the free ACTS or ACTS tool from there. You basically, if you're an American citizen, you've already paid for it. Your tax dollars funded the program that developed that tool. It is free. It is a Java program. I have used it on Windows. I assume it can also be run on any other platform that runs Java, though maybe the GUI might be Windows specific. I don't know. But there's no reason to pay the outlandish fees that some of these companies are charging for these tools when a perfectly capable tool is available for you free of charge. Now, where is this critical? Configuration coverage, where is it critical? Well, basically, anytime you're dealing with portable applications, right? Anything that runs in a browser, mobile applications, these are situations where you really should be addressing configurations. As I said, beware the siren song of the overpriced tool vendor hawking pairwise testing tools and pairwise testing as a magical testing elixir that will fix all of your problems. As I said, it got way overhyped for a while. I think this is kind of starting to die off, but I still do run into situations, especially government contracting. Somehow or another, this really got like latched on like a tick on government contractors, and it's used in a lot of situations where it really shouldn't be. In terms of how to measure the coverage, again, this is a matter of establishing something in your test management tool, in the requirements area, where you just identify specific requirements for configuration coverage, possibly pairs of configuration coverage, and then you're able to measure your coverage against that. Now, data sets. This might or might not be applicable. Depends on what your application does. But if it's you're doing a lot of heavy data processing, and if you can get in and look at your data and do some equivalence partitioning of the data based on the different fields, what kind of values can be in the different fields, then basically what you can do is check to see, have we is our data, our test data, sufficiently diverse and covering all the different things that need to be covered. Now you do have to have a pretty good grasp of the data, which means if the underlying database is a relational database, then you need to have a pretty good understanding of how relational databases work. It's not a relational database, then you have to again understand how it works, and what the how it's actually handling the data, and what kind of data it can and can't handle. Now, one of the things that can happen with non-SQL databases is that they can be more flexible, I guess you'd say, in terms of what kind of data they would accept, which actually does create a problem for you from a testing point of view, because in the case of a relational database, you can generally do some, as I said, equivalence partitioning on the different fields and figure out what is possible in those fields. If there's no such constraints defined in advance, then you're not going to have anything to work with there. But if you can identify the different types of data, again, you can use basically create a entry in your requirements table in your test management tool, and check to see whether you have covered it, and actually measure it that way. Another possible way of doing it is by doing some sort of query analysis on your test data. Now, of course, if you're using production data to do your testing, this you might think of this as superfluous. You say, well, I'm testing every kind of data that we actually have to deal with, and that may well be true. But the thing is that for new features that are added, that might very well be adding some new tables or just redefining the allowed data in a particular table, then your production data, of course, is not going to address that. Now, personas. Personas is a great concept. Well, a lot of times when people think about personas, they start off thinking about role-based testing, which is basically, again, equivalence partitioning the different roles that people will have. It's particularly important with software that has role-based security in it. And so you identify those different roles and make sure that you test in those different roles. And that is part of this, but that's not all of what persona testing is. And so what you want to do is think about not only the roles that people play, but the way that people interact with software. So, you have the kind of the confident power user who sits there and makes entries very quickly. There's very little think time. They navigate very rapidly through the application. Don't make a lot of mistakes. You have the impatient person who, again, navigates quickly but tends to make mistakes. You have the timid person who navigates very slowly and corrects themselves very often and so forth. So you can identify these different user personas, and then if you want to measure them, you again put this into your test management tool as if each persona were a specification element, and then you check to see, have we tested via these different personas. Now, one of the ways that you can do that is just to say you're going to randomly assign personas to people, say at the beginning of the day, and they say, okay, well, today you are supposed to test like a power user. Today you are supposed to test like the timid user. And that way you make sure that there's good proportion of tests spread across each one of the personas. Now this may require a little bit of careful analysis. One of the things I've certainly had to tell testers on a fairly frequent basis is, remember, you are not the user. So don't look at the software through your eyes. Try to look at it through the eyes of the user. So, you might think you understand what a timid person would do, but do you really? Hopefully there are people in your tech support and maybe marketing or business analysts that can give you some insight here as well. Also, just studying the topic of user persona testing, there is a material out there that's been written on that. It's not a new concept at all, so something to look into. Again, this is especially important if you're doing anything that's like a mobile app, a browser-based app, any sort of mass market type of thing where you're not dealing with a captive audience, so to speak, right? For IT applications where people are going to be trained to use the application in a particular way, this can be less important, though still I think it has value even in that setting. All right, defect taxonomies. This is a good one as well. What bugs have you seen in the past? Are you looking for them again? If not, you should be, as it's going to be embarrassing to the entire team, but especially to the testers, if a product is released and in that product there is a bug which was identified and removed in a previous version, is now back. Especially if that bug was found not by the testers but in production the first time, and now it's been found in production again, and people will tend to react to that by saying something like, "Are you kidding me? I mean, it's one thing to miss it the first time, but the second time." So it's a good idea. Keep track of defects that you have found previously, including in production, and test to see if you can make those defects recur again. Basically, the defect report should have the steps to reproduce in it. So that would allow you to quickly use that as if it were a test. The ideal situation is if you can add a automated regression test to your regression test bucket for defects, at least the ones that are found in production. That way you can be sure that it can't, anything that has afflicted a customer once can't come back and be missed. So if you have the ability to do that, that is the ideal thing to do. It is possible to measure the coverage of this. If you're doing what I just suggested, which is every time a defect's found in production, there's an automated test created, and that test then is run every time the regression test bucket is run, then by default you're going to get 100% production defect coverage. And the question is whether you want to add additional ones for defects that are found prior to release. You have to be a little bit careful with a sort of a knee-jerk add another automated test approach to dealing with all risk, because that works for a while, but eventually the tests start to become a bottleneck. It's not possible to predict when exactly that will happen because there are a lot of factors, but it does happen, and we've seen that with clients. But generally speaking, adding an automated test for defects found in production is certainly a good idea. Now, this is of course going to be more useful when you're dealing with a product that's out there. It is released. It's in production. You've got some production data that you can look at. Some production defect data that you can look at. You're building something brand new, then you have to be a little careful with this technique. I mean, obviously you can go out and try to find information on similar applications that other organizations have built and what kind of defects that they have experienced, and that can be a useful input. But are you necessarily going to have that problem? Kind of depends on how similar your technology is and your developers and so forth. Now that said, I mean, there are certainly plenty of like top 25 most frequent bugs out there. There are lists out there. For example, there's a list of top 25 security bugs, and there's no reason not to go after those, because those are ones that are common throughout the industry, right? So certainly look for those, but it is possible that you're going to get off into running some rather obscure tests if you take this too far. So, coverage metrics. We've been looking at different types of coverage, and I've been talking about how to get metrics to measure that coverage. Again, the point here is to help us understand what level of confidence we should have in our testing and in the system itself. You wouldn't want to base that decision on any one of the elements that we've talked about. Again, there's multiple dimensions, so don't make the unidimensional coverage metric mistake. This is quite common in Agile now, where people over rely on, well, we've tested the user story, so therefore, we've tested everything. Now that's just another form of requirements coverage, and you need to try to think beyond just that. Identify the dimensions of coverage that you think are relevant to your particular product, and make sure that you are covering those. And when you report your results in terms of what's covered and what's not. Now, you'll need to help people understand what these coverage metrics mean, but it should be more intuitive to people than just the raw test case counts. Just going into a project status meeting and saying, well, we have 800 tests and we've run 750 of them, and 50 remain to be run, and of the tests that we've run, 720 pass and 30 fail. And if you expect that to be enlightening to people, it's usually not. They will sit there and nod their heads, and of course they understand every one of the numbers, but how exactly that is relevant to the question of where are we in terms of the quality of the product, it's really not. I mean, it's relevant from the point of view of how close are we to being done with executing the tests, but that's a purely tactical question that you need to know as a tester or test manager. It's not, unless there's some sort of reason to think you're not going to finish executing your tests, there's no reason to drag people into the sausage making of that kind of level of detail. Now, as you saw, there are tools that can be used. I mentioned how to use tools to measure your coverage, and certainly you would want to do that. So we'll go into the Q&A session now. I'll put up the advertisement. I always do. Now, I noticed that a couple people were nice enough to refresh my memory during the presentation. The HP's tool now is called ALM, Application Lifecycle Management. Thank you to Elizabeth and Deanna for refreshing my memory on that. Yes, I'd forgotten that. A lot of my clients still call it Quality Center. I guess it's no longer the official name. Let's see. So feel free to submit any questions that you might have. I have a comment here. Hello, everyone. Shailendra, this side from Delhi, India. Well, welcome, Shailendra. It must be quite late at night there. So I guess you're still here. So welcome. Hopefully I'm not keeping you up too late. Let's see. I got an email question. Some people doubt the usefulness of coverage metrics. Why? Why are they wrong? Well, there's been like some sort of general purpose grousing and nitpicking about metrics on the part of a small but very vocal minority in the testing community that have basically said, well, you're not measuring what you think you're measuring, and it's not telling you what you think it is. Metrics, of course, are imperfect, and they have weaknesses, and they can often be gamed if people are incentivized to game them. That said, I could make a similar statement about cars. Cars are potentially dangerous. They are not perfect, and people do misuse them. I could make the same comment about any number of things: knives, guns, cement. I mean, yet, we are still in the early years of software engineering as an engineering field, and we are sort of picking and choosing our way. So I would say to anybody who wants to stand on the sidelines and throw stones at the metrics that we have, until you come up with some credible alternatives, you are nothing but a gadfly and a troublemaker, not a relevant participant in the process of improving software engineering as a profession. The coverage metrics in particular are useful. They give insight into what has been tested and what hasn't been tested. And for those things that have been tested, whether they work or not, they are much more meaningful to people than any test case count, which is the more frequently used reporting metric, and one which is often misleading and very flawed. So, I would say that coverage metrics actually allow us to address some of the issues that exist with other types of metrics by really talking about testing in terms that the stakeholders can understand, and something that actually matters to them. Let's see. So I got I have a question here on test estimation from Kiran. Which technique is ideal? This is not a presentation on estimation. I think I did a presentation on estimation not terribly long ago. It's recorded. The recorded webinar is on the basic library, so go give that a listen. I can't give you it's not a 5-second answer to the question, Kiran, but there's a 90-minute recorded webinar available for you to answer the question. Scott says, in the Air Force, we always start with risk coverage at the top tier. Risk is not system risk, but test risk, which we define as the probability of getting it wrong in test. All other techniques, for example, configuration, flow from that approach. Any measurement of coverage quantifies the risk remaining. Is that a unidimensional approach? I guess you could use a hierarchy like that, right? I mean, because you can make the statement that if I look at the requirement, I should be able to identify a risk that relates to each of the requirements elements. And if not, then I'm missing a risk and I should add one. And you could do the same thing, because you can always talk about risk, and you're talking about risk of getting it wrong in test, basically of a gap in your coverage. So, I mean, I think as long as you get down to the point where somewhere in your analysis you are looking at all of these other dimensions, then no, I would say that's not unidimensional. I don't think it's having a hierarchy in terms of how you approach this is, I think, fine. It's when you say, all I have to think about is X, and I don't have to think about any of these other things. That's when I think you're getting into the unidimensional territory. Scott says, thanks. You're welcome. Deb says, verification versus validation. Our CMMI administrator states that validation testing should only cover marketing requirements, not technical requirements. I disagree. Verification is done in engineering. What are your thoughts? See, personally, I find this concept of verification and validation very useful. Understanding, that in terms of verification, we are verifying requirements, and in validation, we are checking to make sure that the user's problem is actually solved. But I think what the risk is, what can happen is exactly what you're describing, which is a sort of how many angels on the head of a pin kind of thing going on here. It's fine to use verification validation as a concept to make sure that nothing gets missed. I don't think it makes a whole lot of sense to try to use it in the way that's being described here, as a way of like dividing up the work. I mean, I think testing is always going to include some elements of verification and some elements of validation, and as long as you're careful to make sure that the right mix is done in the appropriate areas of testing, that's fine. Now, for this administrator to say that if I cover the marketing requirements, that's sufficient validation, I would say that's definitely not true, because you should. I'll make a deal with anybody who can bring me a perfect set of requirements. I don't care, marketing requirements, technical requirements, whatever. You bring me a perfect requirements document, and I'll bring you a purple unicorn. Okay, and I'm pretty sure I'll never be forced to deliver the purple unicorn. So the idea that because we have covered the marketing requirements, therefore we have adequately validated the product, is very misleading. Certainly not true. Validation definitely needs to go beyond just looking at requirements, and this is part of why I was bringing up these other dimensions of coverage, right? I mean, personas, for example, and supported configurations and so forth might or might not be addressed by the requirements, but certainly it's not going to, the product's not going to solve the user's problem if the user personas aren't addressed, if the supported configurations aren't addressed, etc. So hopefully that was a helpful comment. Deb says, exactly. I like those other dimensions. Great approach. Good, good. So I'm glad I was able to throw you some food for thought. Maybe you can get your CMMI administrator to listen to the recorded webinar, and maybe that'll help persuade him or her that there's more to life than covering the requirements. Abir asks, I hope I'm pronouncing the name right, hello, can you please repeat again the name of the free tool for pairwise testing? I will do better than that. I'm going to send to everybody. It's called ACTS, A-C-T-S, and it is from the National Institute of Standards and Technology, which is at NIST.gov. So there that goes. I just sent out to everyone there. So, yeah, whatever you do. Well, for one thing, don't overuse pairwise testing. Don't do pairwise testing unless you actually need to do pairwise testing. The level of configuration risk justifies it. There's a whole lot of configuration testing, compatibility testing done by third-party test labs. I've worked in one of those before. That's how I got my start in testing. I can tell you that what we do is going to be, most of the time, equivalence partitioning of the supported configurations, not pairwise testing. That said, if you do have to use pairwise techniques, for gosh sakes, don't get fleeced. Don't spend money on a tool that you don't need to buy. Go get the free one and use the free one. If there are any pairwise tool vendors out there gnashing their teeth as they listen to this, sorry, you need to find another way to make money that actually adds value rather than charging people for something they could get for free. Hope that didn't sound too uncharitable. Abir says, thanks. You are welcome. Elizabeth says, do you have recommendations on how to create or elaborate non-specification requirements? Is there a special requirements method or methods to use? Non-specification requirements. Did you mean non-functional requirements? Like requirements for things like performance and reliability and security? Oh, persona. Okay. So to identify the persona, so this is Elizabeth here who added persona to that. There has been some work done on personas and persona-based testing. I think if you were to do an internet search on it, you could probably find some reasonably good papers and articles on what personas are common out there, and therefore which ones to consider. So that's what I would that's where I would start if I were doing it. Now, if you're dealing with the sort of the captive audience scenario, where you're creating a product for internal use, then you know what you would probably want to do is just go and observe some of your users while they're actually using the product and try to get a sense of that. And of course, the thing that should be available and that you definitely need to include as part of this is looking at any sort of role-based security, if that exists, or if there's a role-based functionality in the sense of if you log in and you're assigned a particular role, you see a different set of screens or a different set of functions presented to you if you're logged in under another role. And that can be interesting too, because I have a client that does medical facility administration software, like hospitals and doctors' offices and so forth. And what they said that one of their real challenging tests were that they could have testers that actually, or people, users who actually had multiple roles, and that ended up creating some very interesting scenarios in terms of from a test point of view of what they could and couldn't get to. Okay, so thanks for that question. That was an interesting one. Elizabeth says thanks. You're welcome. Another email question. Are coverage metrics important in Agile projects? Yes, definitely. Definitely a good idea to keep track of what you've covered. Of course, the obvious thing is user stories. That usually happens more or less automatically because of the way that the task boards work. The user story isn't going to be done until the testing on it is complete, or at least it shouldn't be considered done until the testing on it is complete. Now, the downside is that a lot of these other dimensions of coverage will get missed, which is really unfortunate, because you can very easily incorporate risk analysis, quality risk analysis, into the story grooming and estimation parts of the iteration planning period at the beginning of each iteration. So it's easy enough to do. Other similar kinds of things like looking at the supported configurations and the personas and so forth also is something that can be done in Agile. Now, usually it's a good idea for those considerations to actually happen as part of release planning rather than in iteration planning, because if you identify certain supported configurations that you need to test, the time required to procure the hardware and or software could exceed the duration of the iteration. So it might very well be too late. Now, of course, you could say, well, we have this ever-changing product backlog, and that can certainly evolve and change the supported configurations, and that's true. In that case, you might want to consider what's sometimes called rolling wave planning, which is where periodically you go back and revisit some of the sort of longer-term decisions that were made during release planning from a test point of view, including things like what hardware and software might we need, not now, but 3 or 4 iterations from now. Okay, I can tell it's August. People are tired, and the Q&A is not as rowdy as it sometimes is. So we'll wind it down, let you all get back to the pool. So to close this session, a bit more about resources that are available through RBCS. These free webinar sessions run once a month. You can sign up at rbcs-us.com. If you want a special webinar presentation for your company only of this webinar or on any test-related topic, send an email, info@rbcs-us.com, or just contact us via our website. You sign up for our free newsletter at rbcs-us.com. That will also get you discounts on consulting and training services, as well as the newsletter itself. I'm on Twitter, and we are on Twitter, as you can see here, and on Facebook. Do remember to check your email over the next couple days. You may be the lucky winner of the free e-learning course. And again, I'll remind you about the digital library, where we have recorded webinars and other videos and resources. And you can also access that on YouTube via the RBCS channel. We offer these free resources as a service to the software testing community, because at RBCS, we are a not just for-profit company. This concludes the webinar. Thanks to everybody for joining us today. And as I said, I'll go jump in the pool.